Yeah. Good evening, children. This chapter is called Playing with Numbers. Now recall, tell me, what are whole numbers? Okay, first, what are natural numbers? Just tell me. Counting numbers are called natural numbers. Okay, so we know that counting numbers are called natural numbers. I'm not writing that, you know it. Then what are whole numbers? 0. All natural numbers, including 0, form the collection of whole numbers. All right. Now, what are even numbers? Even numbers. Numbers that are divisible by 2 are called even numbers. Numbers that are divisible by 2 are called even numbers. Okay, let me write that. Natural numbers, whole numbers, you know the definition. So you can just make a note of those two terms and then start writing from even numbers. If you want, you can write the definition again. Natural numbers, whole numbers, you can complete it also if you want. Now, even numbers. Numbers that are divisible by 2. Divisible by 2 are called even numbers. Even numbers. All right. Now, even numbers have the digits 0, 2, 4, 6, or 8 in their units place. Okay, or the ones place. Okay, units place. All right. So just by looking at the number, you can say if it is an even number. If the number, however large the number is, if the number ends with the digit 0 or 2 or 4 or 6 or 8, if the number ends with the digits 0, 2, 4, 6 or 8, then that number is an even number. So what's the definition of an even number? Even numbers are divisible by 2. Numbers that are divisible by 2 are called even numbers, and they end with the digits 0, 2, 4, 6 or 8. All right. Odd numbers. Odd numbers. Numbers that are not divisible by 2. Numbers that are not divisible. That are not divisible. That are not divisible by 2 are called odd numbers. Odd numbers. Odd numbers have the digits 1, 3, 5, 7 or 9 in their units place. In their units place. Am I clear so far, children? Yes. Okay, so next we are going to learn about prime numbers and composite numbers. Before that, write down whatever you see on the screen. Quickly make a note of it. Now that you've understood, write down fast. Yes, Santosh, and because you already shared the picture, you know, I know your question paper. We'll work it in the class one day here. Okay? Yeah. Yeah. Question paper. So, share a photo, no? Yeah. All right. Yeah, do it. Yeah, darling.
There was another lesson that we all are accounting tax effect. I noticed in another notebook.
Yeah. Have all the books carefully. Integers. Sorry. Name of the chapter? Integers. Yeah. Yeah. Then you said you have a sports practice, so they will not go ahead, you said, right? So for some time you will not have your regular classes. They'll delay it, huh? So 1 month no studies at school. Correct. Okay, darling. Is it related to this? Okay. Just leave some space. Maybe you can complete it later. You finished? Okay. I'm writing. Yeah. No. Even numbers end with the digits. Now, supposing, they have the digits 0, 2, 4, 6, or 8 in their units place. That is, they end with these digits. So when you look at the number, you can make out if it is even or odd. If I say 99763215570, it ends with 0, no? So it's an even number. Correct? -1 in the chapter integers, huh? It's an odd integer. It's an odd negative integer. It's an odd integer. Odd number, no. If they say odd number, no. Odd integer, yes. Or negative number, or negative number, or integer. But simply odd number means no. Yeah. Next. Exam? Oh, really? No, your handwriting is very neat. But you'll finish first. Done, Santosh, we're waiting for you. Yeah. Yeah. Next, prime numbers. Write down. Okay, please stop writing. Listen to me. A number that has exactly two factors. A number that has exactly two factors is called a prime number. Now, again, the collection is infinite. The collection of prime numbers is infinite. There are infinitely many prime numbers. Now, what do we mean by it has only two factors? Now, when you take this number 19, okay, when you take this number 19, that is 19 is a multiple in the tables of, you will find this number 19 in the tables of 1, in the multiplication tables of 1, and then the multiplication of tables of 19 itself. Will you find this number 19 as a multiple in any other tables? Like 6 ones are 6, 6 twos are 12, 16 are 18. 19 does not happen. Understand? Understand? This number 19 happens, meaning is a multiple in only two tables, two multiplication tables. In the multiplication table of 1 and the multiplication table of 19 itself. In the tables of 1 into 19 is equal to 19. In the tables of 19, 19 into 1 is equal to 19. That answer 19, where do you get that answer, that multiple? That answer 19, where do you get? Only in the tables of 1 and 19 itself. Does 19 happen in any other multiplication table? Do you get the number 19 in the tables of 2? No, 2 9s are 18, 2 10s are 20. 18, 20, 19 does not happen. In the tables of 3, 3 6 are 18, 3 7 are 21. 18, 21, 19 does not come. Am I clear, children? Yeah. Okay. That is so. The factors of 19 are 1 and the number 19 itself. Similarly, 53. 53 also. It will happen in the tables of 1. That is 1 into 53 is equal to 53. And then in the tables of 53 itself, 53 ones are 53. You will not find this number in any other multiplication tables. 2, you will not get 3, you will not get 4, you will not get it anywhere else. So such numbers which have exactly 2 factors, such numbers that have exactly 2 factors are called prime numbers. Prime numbers, because they happen in the tables of 1 and their own tables itself. All right. Okay. So okay, let's do this together. Okay, let's do this together. I've written till 23. Continue from there. 24. No, it comes in the tables of 2. 25. Stop writing. 25. It comes in the tables of 5. 26. No, 2 tables. It's even. No. 26 will come in the tables of 2. 27. Tables of 3. See, it should not. It should come in the tables of 1 and itself. If it comes in any other tables, it's not a prime number. It should come in the tables of 1 and itself. If it happens in any other multiplication tables, it's not a prime number. So I'm continuing from 20. I've written up to 23. We'll write till 100. We'll write all the prime numbers till 100. We'll write the collection of prime numbers till 100. Now 25, I said 25. No, 25 is it prime? Why? Because it happens, stop writing, because it comes in tables of 5. Then 26, 2, 27, 9 and 3, 28, 2, 29. So 29 is the prime number after 23. 30. Same some tables. Which tables? 2, 1. Just tell me 1. That's enough. 2. 31. So 31 is a prime number. 32. 33. 34. 2. 35. 5. 7 and 5. Okay. 36. Every even number will come in 2 tables. Every even number you will say 2, 2, 2. Yeah. So 36, 2. 37. 37. 38. 39. 3 tables. Tables of 3. 3. 13s are 39. Test of divisibility. 3 plus 9, 12. Test of divisibility. 3 plus 9 is 12. The sum of the digits is divisible. Have you learned it? No, no. No problem. No problem. No, no. Now you understand this. 3 into 13 is 39, correct? 3 into 13 is 39. 3 into 13 is 39. So 39 is not a prime number. 40? Yeah. 2. 41? 42? 43, 44, 45, 46, 47, yeah, 48, 49, 50, 2, 2, 5, 10, many tables, 2. Okay, 51, 3 tables. 3 how many times? 17 times 51. 3 17 times is 51. 52, 53, 54, 55, 56, 57, 3 tables. 3 19 times 57. 3 19 times is 57. Then where did I stop? 58, 59, 60, 61, 62, 63, 7, 3 tables, 3, 7, 64, 2, 65, 5, 66, 67, 68, 69, 3. 69 is 3 tables. 3 how many times? 3 23 times. 70, 70, 71. 71, 72, 73, 74, 75, 76, 77, 11, 7, 11, 78, 79. No, the test of divisibility for 3 is 79. What is the sum of the digits? 9 plus 7, 16. Is 16 a multiple? Is 16 a multiple of 3? No, then 79 is also not a multiple of 3. So, yeah, maybe next day. 79, 80, 81, 9 9s are 81. Okay, 3 also, very good. 82, 83, 84, 85, 86, 87, 87. See, just check this out. Sum of the digits. 15. It's divisible by 3 then. If the sum, okay, for 3 alone, you remember. For 3, no, just add the digits. What's the result? 15. Is 15 a multiple of 3? Does 15 come in the 3 tables? 3 5s are 15.
Yeah.
Then 87 also will come in the tables of 3. Okay, 87. Then 88, 89, 90, 91. 13 7s are 91. 92, 93. 3 tables. 9 plus 3, 9 plus 3 is 12. 9 plus 3 is 12. And 12 comes in the tables of 3. No, the test of divisibility for 3, I'm saying. That you should not, the sum of the digits, that test is only for 3, not for everything. Not for everything. No. It's a test of divisibility for 3 and 9. Okay. I'm telling you. Same thing. And 3. So 93, it's divisible by 3 because 9 plus 3 is 12. And 12 comes in the tables of 3. So it's divisible by 3, 93. The 3, 31 times. 94, 95, 96, 97. Yeah. 98, 99, 11, 100, So these are the, I'll write in the next slide, are the prime numbers. Prime numbers from 1 to 100. Important. All prime numbers are dash, except for, you should fill this for me now. I don't know. All prime numbers are dash, except for dash. Dash is the only dash prime number. Yeah. Look at all the numbers. Look at all the prime numbers. What can you say? All the prime numbers are odd. They're all odd. All the prime numbers are odd. Can you see the 3, 5, 7, 11? Meaning all the prime numbers are not divisible. All the prime numbers we see are not divisible by 2. Everybody is odd. You check every number, they're all not divisible by 2, except 2. All prime numbers are odd. Except for, I forgot to write the word except. All prime numbers are odd, except for 2, correct? 2 is the only even prime number. It's an even number and a prime number. 2 is the dash prime number. What? 2 is the same thing. 2 is the smallest. So which is the smallest prime number? 2. Which is the only even prime number? 2. 2 is the only even prime number, and 2 is also the smallest prime number. All prime numbers are odd, even after 100. Not only in this collection, all the prime numbers are odd. Only 2 is the even prime number. All right, now write down quickly, children. And that's only with you and Satakshi. I'll do it. You get the paper to every class. And she's not come today. If you have a doubt with anything, I can tell you a little later. Yes, we'll do that. Because you said you got 19 on 20, right?
19 because 19 out of 20 because yeah, international number name, not Indian number name. That's the. And I got doubt in this. The teacher put it correct, but I got doubt.
I'll clarify that for you.
Yes.
No, darling, I'll come to you. I'll come to you now. Why? Where will you lose marks? You also asked me a doubt. Sorry? You didn't tell me, no? Oh, you said they're not there. No? Okay, I'll come to you. Don't worry. We'll focus on this now. I'll come to you. Write down first. Yeah. She's from Bangalore. Oh, yeah, no, she's not in town. So she's not able to take up the classes. And writing? Yeah, ma, it's a continuation. Are the prime numbers from 1 to 100? Yes, darling, everything on the board. Whatever you see on the board, you must write on your book. Please keep your NCRT book in your bag. Give your question papers to me so that I'll remember to. Ah, yeah, yeah. Exam paper? No, I don't want your paper. Oh, answer paper? Yeah, yeah, please. Take a, yeah, yeah.
Actually, they gave it and they brought it back. Not home. They gave it in the class itself for the marks and check it the photos.
Finish writing, children?
On Monday, they will give it. Monday. Maybe, but writing is important. Study is from
Maths? Oh, very good. Mhm. One second. No, 1 second, children. No, we concentrate on this one. We have lots to talk. Finish writing this. Done? Okay. All right. Next, composite numbers. No, not I would love to listen to all this, but today I have 3 classes. So you will see, you will understand yourself. I won't explain now. Yeah. Yeah. Next is composite numbers. See, we first recalled whole numbers, natural numbers. Okay. Then we understood what are even numbers and odd numbers. Now, prime numbers, composite numbers. See, a number can be an odd number. It can be a prime. A number can be a whole number, a natural number. It can be an even number. It can be a composite number, all at the same time. It's not that if one number it's not that if one number is a prime number, if one number is a composite number, then it cannot be an even number. Not like that. Use it now. Supposing 10. 10 is a whole number. 10 is a natural number. 10 is an even number. Yeah. So it's not that if 10 is a natural number, then it cannot be an even number. So one number can be referred by different terms. One number, this number 10. You will say, if I say something about the number 10, you will say it is a whole number. He'll say it's a natural number. She'll say it's a even number. All right. That's okay. One number can be referred by different terms. Okay. Now, composite numbers. Composite numbers. Composite numbers. Okay, or a composite number. Write down.
Oh.
Done writing? Yeah. Needed? One second. Yeah. This is over. All right. So composite numbers will have more than 2 factors. That is, it will come in the tables of 1. It will come in the tables of itself and at least one other multiplication table. So now 4. 4 is a multiple in the tables of 1. 1 into 4 is 4. And the 4 tables itself, 4 into 1 is 4. Apart from the tables of 1 and 4, it also comes in the tables of 2. So that's why it's a composite number. One, other than 1 in itself, we should have one more multiplication table happening. All right, now if you take 9, it comes, every number will come in the tables of 1 and itself. Every number will come except 1. Okay, every number will come in the tables of 1 and itself. Other than these two, if it happens in at least one other multiplication tables, it's a composite number. It's a composite number. So you can see that 4 is the, we have not included 1 here because 1 is neither a prime number nor a composite number. Santosh, focus. No. Sit. No, I haven't finished still. Now, we have not considered 1 in prime numbers nor in composite numbers, because what is the definition of a prime number? It should have exactly 2 factors, not at least, it should have exactly 2 factors, exactly 2. And what should the 2 factors be? 1 and the number itself. Now, if you take the number 1, it happens in its own tables, 1. And what's the other one? What's the definition of a prime number? It should have exactly 2 factors. It should come in at least 2, exactly, not at least, it should come in exactly 2 multiplication tables. It comes in 1. 1 comes in the tables of 1 and 1 more. So it does not satisfy the definition of a prime number. The definition of a prime number is it should have exactly 2 factors. The factor 1 is the only factor of 1. The factor of 1 is 1 itself. But what's a prime number? It should have exactly 2 factors. So 1 is not a prime number. And 1 is not a composite number also, because a composite number should have more than 2 factors. It doesn't have, it has only 1 factor, that is 1 itself. Then how can it have more than 2 factors? So 1 is neither a prime number nor a composite number. It is called a unique number. 1 is called unique number because we start only the terms prime composite is applicable only for natural numbers, not even negative numbers, only for natural numbers. So 1 is neither a prime number nor a composite number, because if it should be a prime number, it should have exactly 2 factors. 1 has only 1 factor, that is 1 itself. So it does not satisfy the definition of a prime number. So it's not a prime number, it's not a composite number also. So so 1 is a unique number because, sorry, 1 is a unique number. Sorry, yeah. 1 is a unique number. It's neither a prime number nor a composite number. All right. Or something also distracted me. Yes. Correct. Oh my God, by mistake, my bad. Thank you. Sorry, by mistake. You saved me. Thank you. Be careful while writing. Yes. So 4 is the smallest composite number. Very good. Okay. Finish writing all these, children? So far, fine? All right. You finished writing?
Yes, ma'am.
Okay. So now it's about 1. Yes. Yeah. Done? Yeah. All right. All right. So this is about 1. So 1 is 1 a prime number? No. Is 1 a composite number? No. 1 is the unique number. It's neither prime nor composite. The smallest prime number, 2. The smallest composite number, 4. The only even prime number, 2. All prime numbers are odd. Only 2 is even. And 2 is also the smallest. 2 is 2, no, it's the smallest prime number and it is the only even prime number. So we say 2 is, we put both together. 2 is the only even prime number as well as the smallest prime number. 2 is the smallest prime number. 2 is the only even prime number. Correct? Because all the other prime numbers are odd. All the other prime numbers, you see, they are not divisible by 2. All other prime numbers will not be divisible by 2. That's why they are prime. Sorry? Yeah, correct. After 2, everything is odd. After 2, every prime number will be odd. After 2, only 2 is even. Because after that, if it is even, it will have 3 factors at least, no? If it comes in the tables of 2, then they'll have 3 factors, no? At least 3 factors they'll have. Supposing 6. Why 6 is not prime? Because it comes in 1, 6, and 2, and 3. All right. Now, perfect number. The next one is perfect number. Perfect number. Factors excluding. Excluding. A number is said to be a perfect number if the sum of all its factors, excluding itself, is equal to the given number. Not including. Including means count, including that. If you don't include that, it's excluding. Except, yeah. Done? Okay. Now I have another class now from 6:15 to 8:30. So I'll just wind up with this, and I have prepared something else for you, which you will continue doing using that laptop. All right, I've prepared some material for you in the form of fill in the blanks, smash the following, true, false. So even if you don't understand them, I have given you a brief introduction, but there's something more which forms a part of the introduction of this chapter. So if the fill in the blanks or anything there, anything in the material which I've prepared is new to you, just make a note of it. Just write down whatever I tell you to. Okay, we'll continue with that in the next class. You don't have to work anything. It's all with the answers. I've prepared it with the answers. I'll tell you, I'll give you the instructions. I'll come there and tell you. Yeah. You should write everything. You will complete everything now. Answer also you should write. Yes, yes. You should write the answer also. Yes. Okay, I'll just give you an example of a perfect number. Now look at this. Now the factors of 6 are the factors of, I'll say, 28. Okay, the factors of 28 are, see here, write this one. 1 into 28 is 28, right? Then 2 into 14 is 28. 3 tables, no. 4 tables, no. 4 sevens are 28. 5 tables, no. 6 tables, no. 7 tables, 7 fours are 28. Correct? So you stop here. You stop here. So what are the factors of 28? See here, 1, 2, 4, 7, 14, and 28. Okay, the factors of 28 are 1, 2, 4, 7, 14, and 28. And 28. Now, 1 plus 2 plus 4 plus 7 plus 14 is equal to what? Is equal to what? 7 plus 4, 11, 12, 13, 14, 28. It's equal to the number, given number, right? So that means 28 is a perfect number. 28 is a perfect number. Why is 28 a perfect number? We found the factors of 28. Other than 28, leave the number 28 itself and add the remaining factors. Leave the number 28 itself and add the remaining factors. What is the sum you get? 28. So 28 is a perfect number. No, step 1 is, see, you're given a number. You are given a number. You find the factors. You add all the factors. You add all the factors, not including the given number. Not including the given number. You add all the factors. And the result you get is the number itself, the given number itself. Then the number is a perfect number. We'll do more questions like this in the next class. Okay, so don't worry. There is another definition for a perfect number, which I'm not telling you now. I'll do it in the next class. Have you, 1 minute. What are you doing? Finish writing? Wait, 1 minute. Finish writing this? There's another definition for a perfect number, which I'll tell you in the next class. Because the material which I have prepared, I've given the other definition. So don't get confused. Okay? All right. All right, children. So I'll stop the meeting now and you can continue from the other laptop. All right? Yeah.